The following program contains graphic images that some viewers may find disturbing. Viewer discretion is advised. Genetic diseases that can kill. Mental disorders that ruin. Is this a fact of life or a destiny we can change? Now there is room for optimism. Each day a group of scientists toil, hoping to make a miracle out of the microscope. Stem cell research and Singapore, bringing new hopes for age-old problems. Health, our new wealth. As we build our physiques, some in a Southeast Asian nation are also fortifying us. Their tools, minuscule but mighty. Stem cells. Strong government support, world-class facilities, and an impressive legacy has made sunny Singapore an Ibiza for research haven. In 1994, Professor Arif Bongso and his team from the National University of Singapore was the first in the world to isolate human embryonic stem cells. In 1995, a team from 2 Singapore hospitals scored another global first, using cord blood stem cells to treat a boy with a blood disorder. These achievements soon set the pace in a global race to harness stem cell power, with Singapore so far emerging as a research bigwig and a global biomedical hub. So what is the magic behind stem cells? You could say they're your body's medicine chest. They make new cells to replace the ones that died, either from injury or disease. Medical science may have evolved to sophistication, but we remain vulnerable. Cancer, diabetes, leukemia, Alzheimer's, congenital heart failure and schizophrenia, just to name a few. Fortunately, stem cell therapy is offering new hopes and possibly new leases of life. Stem cells renew, rejuvenate, give birth to new cells. When there are new cells, healing begins. For now, most stem cell therapies are still in research stage, not yet as formal cures, but one island state is pushing on. First up, a branch of stem cell research that has brought Singapore to the limelight. The human embryonic stem cells, or stem cells from the human embryo. Much debate has arisen over its use. Many biomedical hubs like the United States and Germany have remained reticent in human embryonic stem cell research, citing ethical concerns. Singapore, on the other hand, offers the refreshing alternative. Here, research conducted on an embryo is permitted, only if it hasn't turned 14 days old. After that, it is deemed unethical, as the embryo should be considered a living person. Singapore allows human embryonic stem cell research, but only within such regulatory measures. Because of this flexible framework, world-class researchers have begun to flock here. One member, Dr. Alan Coleman, who's best known as the man who helped clone Dolly the sheep in 1997. Having worked in various parts of the world, Dr. Coleman arrived in Singapore in 2002.
Jokingly, I could say that I don't find much Premier League football in the USA, and I find a lot in Singapore. And to someone who's come from the UK, that's very attractive. But more seriously, it's the enthusiasm and the commitment of the government to support certain areas of research. We've been able to get on with research here with world-class facilities.
To date, Singapore has spent some $2.1 billion in the biomedical sciences. This bodes well for the future of human embryonic stem cell research here.
I think stem cells as a general medicine are already hitting the market in a slow way. So we want to make a contribution and we want it to be substantial. What we want to do is something significant and help people.
But the immediate goal for Dr. Coleman and his team is stem cell research for the understanding of diseases. One project in the works, studying schizophrenia. Schizophrenia is a mental disorder that may cause hallucinations or the often reported hearing voices. Classic example, thinking someone is goading you to do something, someone fictitious. This condition occurs when there's a disorder in the central nervous system. And Dr. Coleman's colleague, Dr. Jeremy Crook, aims to create a model based on this.
Well, it's a widespread disorder. About 1% of the global population experience schizophrenia at an extreme cost to the community in terms of treatment.
This is what a schizophrenic brain scan may look like. The green spots are the disease cells. And Dr. Crook aims to create sort of a replica of these parts that have gone awry. One of the building blocks, human embryonic stem cells. Here, the stem cells are modified to carry the schizophrenic defective gene. By studying the defective cells, the team can then better understand schizophrenia, possibly identifying a drug compound that will return the defective gene to normal.
So really these models are a way to discover new therapies, new drug therapies, to treat schizophrenia, as well as better understand the cause and pathology of the illness.
Coming up, when the daily shave becomes bleeding episodes and football turns fatal, see how the humble umbilical cord can save lives and provide new hope for those with a rare blood disorder and severe skin wounds. Having gained international repute for its human embryonic stem cell work, Singapore continues to raise the bar. An enterprising scientist here has discovered a source of stem cells, sealing the Republic's status as a research powerhouse. Cell Research Corporation is a Singapore-based startup, providing cell strains, culture media and support services to researchers and businesses globally. Its biggest claim to fame? A breakthrough discovery in 2005. Here in the delivery room, the baby's the highlight. But there's something else special, and Dr. Fan Tong Tang, one of the founders of Cell Research Corporation, was the first to notice.
The moment the baby is delivered, all attention is focused on the baby and the mother. By this time, everything else is called the afterbirth.
But Singapore-based scientist Dr. Fan, who hails from Vietnam, found that the outer lining of the umbilical cord is an amazing source for stem cells. The world sat up and took notice. Stem cells from the cord lining was novel. Previous sources came mainly from the adult human body or from human embryos. But Dr. Fan's eureka was a serendipity. He had his eyes on something else for stem cells.
The real story behind this is that Dr. Fan had come across the placenta as a potential source of stem cells. However, he was unable to get any good placental membrane from which to get the stem cells.
In the first place, the placenta was hard to decontaminate due to its bloody surface. Not one to be daunted, Dr. Fan found his next inspiration fast. Next to the placenta lay a bottle of umbilical cord. He tested the sample for stem cells, and the rest, they say, is history. An immediate boost for the global research community. Cord lining stem cells provided greater quantities to work with compared to other sources. Say you're a scientist. You want to do your research on stem cells, but there's just not enough of them. You either keep growing more, what they call culturing, or you wait for stocks to arrive. With cord lining cells, shortage woes may be a thing of the past. This cord here is about 55 centimeters long, but it holds some 6 billion stem cells. With Dr. Fan's discovery of cord lining stem cells, the researcher's life has been made easier. And its potential doesn't end here. Using cord lining stem cells, Dr. Fan's researching treatments for those with severe skin wounds in Vietnam, and the results have been encouraging. His remedy: Cord-lining skin stem cells are first cultured on a scaffold. The new cultured cells are then applied on the wound. This long-suffering Vietnamese patient managed to close his wound in a week after stem cells helped grow new skin cells for him.
Interestingly enough, the cells which we grew on scaffolds, what the cells were used for initially was really to increase what we call granulation, i.e. wound bed readiness to accept a skin graft. To our surprise, we found that in the first few patients, not only did we improve the wound, we totally resurfaced it.
Dr. Phan also mixes umbilical cord lining stem cells in a gel form to treat severe cavity wounds. The treatment has saved Vietnamese diabetic patients from undergoing leg amputation. And Dr. Phan's team has found another spin-off technology. Outside the human body, stem cells disintegrate quickly. In comes Dr. Phan's condition media. When bathed in this liquid, the stem cells absorb nutrients better. Their response? They secrete proteins. And these proteins do wonders. They repair skin and could possibly be developed into portable treatments for battlefield injuries.
Cord-lining stem cells, like any other cell, talk to each other by releasing proteins. The proteins, they encourage cells to divide. They are replacing what is missing, and they're taking away what is not required. They're balancing the environment to allow the cells to grow once again.
Cord-lining stem cells are increasingly being used by researchers from around the world. One of them is Dr. Con Oi Lian. Using cord-lining stem cells from Dr. Phan, her research aims to treat a rare blood disorder that occurs once in every 5,000 to 10,000 male babies born. Football and rowdy games, all part of being a boy. For those with an unusual blood disorder called hemophilia, rugged pursuits strike more fear than fun. Hemophilia is a disorder where one's blood doesn't clot normally. When grazed, a hemophiliac may bleed longer. A small cut can even turn fatal for those with a severe condition.
Children who have hemophilia tend to get very severe bleeding under conditions of normal activity, such as playing football. But the main areas that are dangerous would be if they bleed into the brain.
2/3 of haemophiliac children are in developing countries. It would cost about $300,000 a year to treat a haemophilic patient optimally, and most can't afford it. The effects of haemophilia can be controlled, but some in Singapore are looking towards better treatments. And Dr. Con Oi Liang's team is doing just that. One type of haemophilia they're studying involves a gene that has malfunctioned. This gene isn't producing a substance that makes blood clot normally. That substance is called factor VIII.
It produces a very large protein which is essential for blood to clot. So without factor VIII, you don't clot your blood as easily.
When you have a cut, blood leaks profusely. Notice it tapers off after a while. A scab may form. This is called clotting, and factor VIII is responsible for it. Unfortunately, haemophilic patients lack this clotting factor. Much of Dr. Con's work aims to introduce this blood clotting factor into cord-lining stem cells. Her eventual vision is for these modified cells to be transplanted into the patient's body. So far, Dr. Con's research hasn't reached clinical trials. Instead, her team is currently introducing the factor VIII gene through a transplant of cord-lining stem cells into haemophilic mice. Results so far have been heartening. When human cord-lining stem cells were placed in mice during the research process, there were no signs of rejections until the 7th to 14th day. This is significant, as our bodies are designed to reject tissues that aren't our own. Imagine our body is like water. If you put foreign things inside, it won't merge. Likewise, our body will also reject foreign material. But when you put in a liquid, it's different. Similarly, Dr. Con's test suggests our body will be tolerant to cord-lining stem cells, just like two liquids mixing well. What is the magic behind cord-lining stem cells? The secret could be the source. They come from the umbilical cord, which rarely belongs to the fetus. A point to ponder. If a fetus is a foreign tissue in a mother's body, shouldn't the mother reject it physically? Dr. Kon and her team believe the umbilical cord has a unique quality that's causing the mother's state of tolerance for the growing fetal tissue. And cord lining stem cells have developed this quality.
Well, I think if we manage to show effectiveness in a clinical trial, we'll bring quite substantial benefits to many hemophilic patients, especially in the developing countries where they either cannot afford any treatment or are very poorly treated.
After the break, the humble umbilical cord proves its medical wonder yet again. See how cord blood stem cells are treating some of the most aggressive blood diseases around. Babies, miracle of life and sometimes source of life. Dr. William Huang is medical director of the Singapore Cord Blood Bank. Cord blood is what the baby leaves behind after birth. But to Dr. Huang, the story has just begun. When the baby is delivered, the umbilical cord is snipped. Inside this cord is blood that could potentially save someone's life. The baby doesn't need it anymore, but someone else does. And the first step is for the obstetrician to collect it at its freshest. After that, to the bank it goes, where the intensive work begins. The sample is first checked and its volume assessed. The white blood cells are then separated from the red blood cells and plasma. The white blood cells are the focal point, because that's where life-saving stem cells are. Next, off to the cell counter to check for the number of viable cells present. Those that make the mark will be banked. Their final resting place, this cryopreservation room with liquid nitrogen tanks at minus 190 degrees Celsius. The cord blood stem cells will be stored until they're called for a transplant.
The use of cord blood is mainly to treat blood-related diseases. The best source of these cells is from healthy cells of another individual, such that they are able to replace the bad cells, either from bad because of disease or genetic disease of a patient.
But cord blood has its limitations. Suitable for children, not so for adults. Bigger in size, adults need larger quantities during cord blood transplants. Addressing this issue has since been one of Dr. Huang's research priorities.
It is widely used in pediatric patients because pediatric patients are small relative to the cord blood unit. But for adult patients, sometimes there are insufficient cells available for transplantation.
Researchers around the world have been trying to expand cord blood cells in culture to provide sufficient numbers for transplant, but no one has devised a satisfactory method yet. In comes Dr. Huang's team. They're going to use two existing methods to expand cord blood cells. The first technique is from the Johns Hopkins University. Its driving force, mesenchymal stem cells, or MSCs.
Mesenchymal stem cells are special types of cells. They tend to form a layer when you grow them in culture, and they have certain special properties. Now, one of the special properties that we found is that they could support the growth of cord blood cells in culture. And they do this by kind of keeping the cord blood cells alive and happy.
But Dr. Huang isn't satisfied. He's going to use the second technique, which originates from the Massachusetts Institute of Technology. One key feature, the use of two kinds of protein that seems to add a touch of magic, efficiently expanding the cord blood cells to much desired results.
When we combine both techniques, we found that we were not only able to get cells of a much larger quantity, but also that we had better quality of cells.
Promising results indeed. If all goes well with Dr. Huang's research, 1 unit of cord blood could soon create multiple wonders. But a good workman needs his tools. Dr. Huang's research samples hails from gracious donors to the Singapore Cord Blood Bank. Juliana has just signed up for the bank's cord blood collection program. One day when her child is born, his umbilical cord blood may save a life.
I feel that My cord blood usually would be discarded, after the delivery. So I decided that instead of putting it to waste, why not I put it to good use for a good cause.
Be it for transplants or research, Juliana's goodwill is in equally good hands. Dr. Wang has set his sights for a possible clinical trial to implement his cord blood cell expansion techniques. Around the world, more than 10,000 have been treated successfully by cord blood cell transplants, and Dr. Wang is determined to add to the number. All part of the plan, to be a global hub for stem cell therapy. But Singapore's not done with its ambitions. Stem cell researchers around the world watch this space. The Singapore Stem Cell Bank. Attention researchers, you may pick up your stocks here. The bank aims to be an important global provider for stem cells. Why pick them? 2 words: convenience and quality. Clean and clinical are the order of the day at the Stem Cell Bank. The bank is one of the few in the world that operates according to the good laboratory practices. This means uber-clean environments and stringent quality controls in the stem cell expansion and storage processes. While quality is paramount, the service is fuss-free and accessible. Dr. Crook aims to facilitate the work of researchers globally. Imagine online shopping for cells. For $550 you get 1 straw of human embryonic stem cells at premium quality and a reasonable price. All this with a click of a button.
I'm confident that in time, researchers around the world will be able to demonstrate the utility of stem cell on all sorts of levels.
Stem cells, minuscule but mighty. Cord blood stem cells have proven to be effective therapies for some of mankind's most debilitating diseases. Will cord lining stem cells and human embryonic stem cells boast the same potential? It may be some time before we can be sure, but the researchers here are persevering. Thankfully, it's a mission many have also pledged to take part in. Some of them quite the unlikely hero.